In this video, we're going to look at saving arithmetic by using the cumulative binomial tables. If we take an example for random variable x belonging to a binomial distribution 30, 0.35, A, find the probability that 7 is less than x is less than or equal to 15, and B, find the probability that x is greater than 13. Okay, we're using x as a binomial with n is 30 and p is 0.35. To start with, in part A, we need the probability that 7 is less than x is less than or equal to 15, which is the probability that x is 8 or 9 or 10 or 11 or 12 or 13 or 14 or 15. And I really don't want to work all that out. Fortunately, our formula booklet has some probability tables for what we might call nice numbers. These tables are on pages 17 to 21 in your formula booklet. If we look in the formula booklet, we can see that the probability that x is less than or equal to 15, we look in the formula booklet for n is 30, p is 0.35, we go down to the row x equals 15, and we find the number 0.9699. So there's the probability that x is less than or equal to 15. In the example that we have, the probability that 7 is less than x is less than or equal to 15. That is the probability that x is less than or equal to 15 minus, now the probability tables always refer to less than or equal to in each row. So we must put something in here which is going to work. X less than or equal to 7. So if we take everything up to 15 and take away 7, 6, 5, 4, 3, we're left with 8 up to 15. I don't know why I wrote implies. This is now equal to probability x less than or equal to 15, we've just done, 0.9699. If we go back to the tables and we look in n is 30, p is 0.35, go down to the row of 7, and we find the number 0.1238. Subtracting the two of them, we get 0.8461, and we give that answer to 4 decimal places because this is an answer which comes from using the tables. We are expected to give all figures if using the tables. So that's a nice simple example, and you should be able to cope with the cumulative probability tables without too much trouble. There is one slight problem. You might have noticed if you look in the probability tables, the cumulative tables, that it doesn't have anything for p greater than a half. So if p is bigger than a half, how do we use the cumulative probability tables? Okay, let's get a clean page, well, nearly clean page. Example. Let's have a look at another example. Suppose we have a bag which contains a large number of red and white discs, and 85% of those discs are red. We take 20 discs from the bag. find the probability that the number of red disks in those 20 disks lies between 12 and 17 inclusive. Looks very much like the problem we've just done. Let's suppose that x is the number of red disks. Then this tells the method, this is the explanation of what you're doing, and x is binomial 20, 0.85. Essential to write that down in any solution. What we're looking for is the probability that 12 less than or equal to x less than or equal to 17. Inclusive, so less than or equal to in each time. To start with, this looks just like the problem before until we realize that the probability p is 0.85 and the tables don't go above 0.5. So we need to turn the problem backwards, and instead of looking at the number of red disks, we need to look at the number of white disks. So let's now consider y is the number of white disks. Then y is still binomial. We still have 20 in the sample, but if the probability of a red disk is 85% or 0.85, the probability of a white disk is 0.15. Now we can use the tables. We can look in the tables where n is 20 and p is 0.15. What are we looking for? We're looking for 12 less than or equal to x less than or equal to 17. This gives us that x is 12, 13, let's just put a proper equals sign in, 14, 15, 16, 17, or 18. It is worth writing out the numbers. If you try and do, whoops, I don't need the 18, sorry. It is worth writing out the numbers. If you don't put the numbers in, then it's easy to make a mistake, other than the one I've just made. So, remembering that x plus y is 20, we have 20 in total. If x is 12, then y is 8. If x is 13, y is 7, 6, 5, 4, 3. So the probability that 12 is less than or equal to x is less than or equal to 17 is the probability that 3 is less than or equal to y is less than or equal to 8. Now I can go to the tables. I'm using the probability that white is 0.15, which is less than a half, so I can go to the tables, and we're looking for the probability that y is less than or equal to 8 minus, now think a little bit here, the tables only deal with less than or equal to. It's very easy just to write down 3, but it's wrong. We want to include 3 in the previous line. 3 is included there. If we write less than or equal to 3 here, we're taking the 3 away. So we actually want less than or equal to 2. Looking in the tables, we get y less than or equal to 8 is 0.9987. Take away less than or equal to 2, 0.4049, which gives us 0.5938. Again, to 4 decimal places, because we are using the tables. The work on the cumulative binomial probability function, the tables, is found in your textbooks S2 on pages 9 to 12. One word of warning, in the textbook they do very little on the questions where the probability P is bigger than a half. You'll find in the worksheets that I give you, there will be a few questions to help you sort that one out.